Hi friends, welcome to Data Science and AI Quest. In this topic, we will be looking into the topic of computation of arithmetic mean by assumed mean method. In this method, we will be looking into a method over where a mean of a table data could also be carried out or could be computed in hand with the method which is known as assumed mean method. So in this assumed mean method, what we have taken into this example is a table over where income of different families, that is 10 in number, has been taken, and their income range has also been taken, which is according to weeks, and then afterwards a deviation, and then afterwards assumed mean from the deviation is also taken. So here we'll go through the example. The data shows the weekly income of 10 families, that is family A, B, C, D, E, F, G, H, I, J, and the weekly incomes. So the weekly income of family A is 850. The weekly income of family B is 700. The weekly income of family C is 100. The weekly income of family D is 750. The weekly income of E is 5000. The weekly income of F is 80. The weekly income of G is 420. The weekly income of H is 2500. Then I is 400 and J is 360. From this, we have to compute the mean family income. So in this table you can see that A is having a weekly income of 850. So the assumed mean has been taken as 850 over here, and then in the next column we'll be finding out the deviation, that is deviation of the income from the assumed mean, and then afterwards we would be taking out the per capita deviation, that is the deviation from the total number of observations. The number of observations in the table is 10. So row wise we can go, like family A has an income of 850, and as because we have taken the deviation as 850, the deviation would be shown as 0. Then the per capita deviation, the mean per capita deviation is shown to be 0. Then families B is taken, the income is 700, the deviation is minus 150, and the per capita deviation is minus 15. Then family C is taken, the income is 100, the deviation is minus 750, and the per capita deviation is minus 75. Then family D is taken. The family D has a income of 750. It has a deviation of minus 100. It has a per capita deviation of minus 10. Then family E is considered, its income is 5000. Then the deviation is plus 4150, and as per the notation for the per capita deviation, it is plus 415 for E. Then family F is considered. Here the income is 80, so the deviation comes around to be a minus 770, and the deviation per capita is minus 77. Family G is taken, 420 is its income, then deviation is shown to be minus 430. Then per capita deviation is minus 43. Then family H is taken, income is 2500, deviation is 2500 minus 850, which is 1650. Then deviation, per capita deviation is 165. Then family I is taken. Here the income is 400. Then deviation is 400 minus 850, and it comes around to be minus 450. And the per capita deviation is coming around to be minus 45. Then family J is taken. Family J has an income of 360. Then its deviation is coming to be 490 minus 490. Then the per capita deviation is coming to be minus 49. So the arithmetic mean using assumed mean method can be computed like x bar is equal to a, that is the assumed mean, plus summation of d, that is the summation of the deviations, over capital N. Capital N is the number of total observations, and here it has been computed. The assumed mean is 850, and the summation of all the deviations is coming around to be 2660, and the total number of observations noted over here is 10. So the per capita the mean computed by this method, that is the arithmetic mean through the assumed mean, is found out to be 1116. Thus the average weekly income of a family by both methods, that is the mean method and as well as the assumed mean method, which computes the deviation from the mean, that is the assumed mean, and its summation, is found out to be as rupees 1116. So this can also be computed using the direct step deviation method. In the step deviation method, the calculations can be further simplified by dividing all the deviations taken from assumed mean by the common factor C. The objective is to avoid large numerical figures, that is, if D is equal to x minus a, which is very large, then one needs to find the D cap. This is done as follows. The D cap, that is the deviation cap, is computed as D by C, which is equal to x minus a by c. The formula for the following is given below. X cap is equal to a, that is the assumed mean, plus summation of all the deviations over the total number of observations, that is n, multiplied by c, that is the common factor. And by this you can get that D cap is equal to the x minus a, that is the mean minus the assumed mean, by the common factor over the common factor. Now we get to see that C is the common factor over here, that N is, capital N is the number of observations, capital A is the assumed mean. Thus one can calculate the arithmetic mean in the example by the step deviation method, and it gets to be 850 plus 266, that is the summation of all the deviations, 266 over the total observations, that is 10, multiplied by the common factor, that is C. So one can get to see that the assumed mean which has been found out comes to be 1116. So I hope the concept of Finding out arithmetic mean by assumed mean method is somewhat clear. So thanks for watching, and stay tuned. We'll come with more advanced topics in statistics and data science in the following examples. Thank you.